Howdy everybody, and welcome to part 2 of the Understanding Neovim series. So in the last episode, we defined the most basic options that are to tweak our Neovim experience and to make it more consistent and generally nicer for our purpose, which is general writing and programming. In this episode, we are going to deal with the more complicated stuff. We are going to set up a plugin manager and we are going to install a color scheme. Alrighty, so this is the init.lua that we had from last episode. Now there are a few changes in this second video that I made. First of all, I enabled screen key, so whenever I perform some motion or I press something on the keyboard, you're going to see the changes here. That should hopefully prevent any sort of confusion or annoyances like, how did you do this? Now you know. And also you might see this line that enables the scroll offset, which we set in the last episode. I commented this out just for this series. You should leave it as is in your configuration. The reason I disabled it is because as I'm showing you stuff around and clicking around with the mouse, if you have the scroll offset set to 999, it's going to make the screen jump around a lot, which might be a bit jarring. So just for the sake of this series, I've disabled it, but if I were making a serious config where I would be the one using it every day and I wouldn't even be touching the mouse because I'd be doing everything through the keyboard, I would absolutely have this option enabled and set to 999. I don't believe I touched on this in the last episode, but what are these double dashes over here? Not everybody has to be a programmer, right? This is a comment. And what that means is that whenever Lua encounters double dashes here, so 2 dashes, everything from these dashes to the end of the line is going to be ignored by Lua. What this means in this case is we're just removing this line of code from the sight of Lua. In a way, it's not going to see this and it's going to therefore ignore this. The added benefit is if I ever want to re-enable this, I can just go ahead and remove the comment line and now it's here. So you could think of it as a way of archiving something instead of deleting it. But comments are also useful if you want to annotate your code. Say for example, you're writing out a config which you know your future self is going to look at like 1 or 2 years later down the line, and you might want to leave some explanations in your code for your future self or for anybody else reading your code. For example, this unnamed plus name here is a bit uninformative, like what is this? So you could go ahead and add a comment above this line explaining what this line of code does. Here's an example. Right, I could add a description here which says this line of code synchronizes the system clipboard with Neovim's clipboard, and then whenever you're going to be reading this code sometime in the future, you're going to encounter this line and go, oh, this is what it does. Your configuration should look like this, but my configuration is going to look like this. That is the only difference we are going to have in between our configurations. So for starters, I would like to add some extra config options which we didn't have time to discuss or to add in the previous episode. So the first option I would like to discuss is this tabstop option here, because this is actually, unfortunately for us, not the end of the story. Just because we set the tab stop to 4 doesn't mean that Neovim is going to treat absolutely every tab as 4 spaces. So tab stop is an instruction to Neovim when saving the file, how it should convert spaces to tabs, and also when opening the file, it's a visual guide how much spaces a single tab should occupy. But there are motions that we can perform within Neovim when editing text, and while we're editing text, Neovim actually looks at a different variable. So I'm going to introduce you to 2 keybinds, and these are the indent and dedent keybinds. You might know these, you might not know these. What they do is they indent a line of code and they dedent a line of code respectively. Now I'm on this tab stop line, line 10 over here. And to indent and dedent, we use the angled brackets on our keyboard. So the greater than symbol, if you press that twice, that's going to indent the current line to the right. If you press the less than symbol twice, it's going to dedent the current line. So it's going to go to the left. And what you'll see is that despite having tab stop set to 4, if I indent the current line, you'll see that this is way more than 4 spaces. In fact, if I select this region visually with the mouse, or I can select it normally with visual mode over here, you'll see that down at the bottom, Neovim is telling us that this region occupies 8 spaces. So what gives? I mean, we set it to 4 over here. So there's another option, and that option is called shift width. You can see the help page for that. Now make sure you're selecting the variable, which is going to be in apostrophes or in single quotation marks, instead of the function, which is going to have brackets appended on the end. We want the variable, and you can see that the shift width is the number of spaces to use for each step of auto indentation. It's used for cindent, the indent operator, and the dedent operator. the two that we just learned earlier. Now, as you see, the default value for this is 8. Okay, so now we understand why it was indenting things incorrect. You will see that it says when 0 the tabstop value will be used, which could be interesting. We could set shift width to 0, and then it's going to fall back to our tabstop. But I actually don't like doing this, and the reason why I don't like doing this is because it's very uninformative. Like, you're setting shift width to 0, and unless somebody knows that setting it to 0 means falling back to tabstop, it might just end up being more confusing than anything. So I will exit out of this window, and instead of setting it to 0 and doing some weird magic, we're just going to also set it to 4 to make sure it's consistent with our tabstop. Okay, that is looking good. So if we save and quit and try to re-enter our Neovim configuration, hopefully if we indent something now, it's going to only be 4 spaces instead of 8. All right, let me go down here and indent. Voila, that is much better. Okay, so the next option I would like to change is quite an advanced option. And I think once you change this, you're going to use visual block mode a lot more than you currently do. What do I mean by this? There are many modes in Neovim, as you probably know. There's insert, there's normal mode, there's visual mode. There are also some other modes that aren't as common, and there are also sub-modes of the visual mode, believe it or not. There's the regular visual selection, and then there's also visual block mode. Theoretically, there's also select mode, but yeah, we don't talk about that. Visual block mode differs in normal visual mode, and let me show you how. So I'm going to go up here to this line with shift width, and I'm just gonna go on this T right here, and I'm going to enter visual mode normally with V. If I then move upwards, you see it behaves kind of normally like a visual mode would, right? It's selecting all of the text in between the beginning of the selection and the current location of my cursor. Now, if I go back to the shift width over here, and instead of pressing regular V, I press Control V, it's now entering visual block mode, and you can see down at the bottom, Neovim is even telling you the mode. Now, if I move up and to the left, you can see it's creating a square instead of a regular visual selection. And this is useful for all sorts of editing tasks, especially if you have something like this, where vim.opt exists at the beginning of every single line. If I wanted to change the beginning of every single line, I could Control V, select these 3 lines, move to the beginning of the line, hit C to change, and then I could, for example, type some just random text, and when I hit escape, it's been changed for all 3 lines. So what is the behavior I would like to change here? If I now go to this equal sign, you don't have to be doing exactly the same thing I'm doing, by the way, I'm just showing the behaviors. If I go to visual block mode and I try going past the line, you can see we start getting some pretty annoying behavior. It's no longer creating a block. It's no longer creating a block because the lines aren't of equal length. So it's only highlighting up to the end of the line here. And I'm unable to move further to the right. My cursor is unable to move further, right? It's the end of the line where my current cursor is at. This is very mildly infuriating and deters a lot of people from actually using the visual block mode. But we can actually alter this behavior with a special option called virtual edit. Now, virtual edit is super cool because what we can tell virtual edit is, in certain circumstances, I want you to treat the entire screen as a set of different cells. Right now, the document is split up into cells, right? One cell for each character. And you can see your cursor is even highlighting the current cell that you're in. But you can't go past the current line because the line only spans a set amount of spaces, right? A set amount of cells. With virtual edit, however, what we can do is we can completely remove this limitation. We can divide up even the empty spaces in the document into individual cells. This is a pretty good summary. Virtual editing means that the cursor can be positioned where there is no actual character. Now, you can define virtual edit in all sorts of scenarios. I like setting virtual edit to just work in visual block mode. It's a bit jarring in all of the other modes, but in visual block mode it's particularly useful. So we're going to set virtual edit equal to block, and when we re-enter Neovim, I'm going to show you how this can really change the whole editing experience when you're dealing with visual blocks. Okay, so we're going to set virtual edit to block, as I said, and now we're going to save and quit and re-enter Neovim. Let me now go to line 8 and to the equal sign, and I'm going to now enter visual block mode, go down, and now look what happens when I start moving to the right. You can see the problem has been completely eliminated. It's selecting a block despite there being no characters here and here. And I can continue going past the line to select even this top bit, this true. Theoretically, I can go even further now because it's treating the whole window as a sequence of cells. You are also free to experiment with like virtual edit equals all or for insert mode and see how that affects the editing experience. Don't be afraid to like play around with options. It's not gonna ruin your Neovim or anything like that. You can just revert convert the changes very quickly. Next up, we have the ink command option. And no, it doesn't have anything to do with ink. Instead, it is a short for incremental. So once you get accustomed to the more advanced Neovim commands, like for example, the global search and replace, you're going to see that it might be useful to be able to preview the changes in real time. Now there is a preview built in by default, and let's see what that looks like. I can run %s, which is going to perform a substitution across the entire document, and I can tell it to replace, for example, the word vim with the word nvim, just for demonstration purposes. And you can see as I type, it's already showing me the live preview of this. And that's great. I mean, if I were to actually then accept this, it's performed all of the changes within the entire document. But I'm going to press U to undo here, and also I'm going to run the no highlight search command, which is going to remove all of the searches, in case you didn't know how to remove that, now you do. And we're going to set this ink command option to split. You can set it to a few different things. As always, consult the help pages, see what available options there are, but we're going to set it to split. And what this is going to do is this is going to split the window, and it's going to create kind of like a split window down here, and it's going to show us all of the changes in real time. Let's see what that looks like. All right, we're going to now try to run the substitution again, and immediately as soon as I hit slash, you see this split enabled down here. It's showing you the line number where the change is occurring, and it's showing you all of the changes sequentially. In this init.lua, this might not be as useful, but if you have a very large file where these different changes might be very far away from each other, this split down at the bottom proves to be very helpful, and that is why we're setting it for this series. Okay, next up, we're going to set the ignorecase variable equal to true. This is another personal favorite of mine because I'm a lazy person and I don't like dealing with casing a lot. Let me show what I mean. If a command is inbuilt into Neovim, right, it's built in, then it's always going to be lowercase. For example, echo, or for example, the substitution command, as you saw, that's also a lowercase. If anything is an extension, or if it comes in the form of a plugin, its commands will always have to be uppercase. This is a convention that is enforced by Neovim. If you're a plugin developer and you try creating a lowercase command, Neovim is not going to let you do that. So this creates a very nice distinction. If you're running a command and it's lowercase, you know it's built into Neovim. If you're running a command and it's uppercase, then it's coming from some external source. Neovim has a bunch of built-in plugins, believe it or not. Even though you might think this editor is very, very minimal, it's actually not so much. It has quite a few things embedded into it. And an example plugin that is vended with Neovim is netrw. So if I run net, and I hit tab to see all of the completions, you can see that we have net user pass, netrw clean, and netrw settings. Now the annoyance comes when I try to type lowercase net and I hit tab to complete. No completions show up. That sucks. But we can tell Neovim to actually ignore casing throughout the editor. Right, setting ignore case equal to true. Leave Neovim, re-enter Neovim, and now type lowercase net. If you hit tab, it's going to now successfully complete all of the entries for netrw. And indeed, here they are. And now, last but not least, the last option we are going to change, at least for this episode, is going to be the termguicolors option. This seems like such an odd and a completely random option to change, but it's actually going to prove to be very important. It's quite a technical option, so I'm going to try and explain it now. So terminals are pretty old pieces of tech, you know? The OG terminals would print the results of operations on paper. So by default, Neovim actually goes with a pretty conservative set of colors. In fact, currently, Neovim is using the colors from my terminal's color scheme, which is maybe why it looks better than on your machine, or perhaps even worse than on your machine if you have like a really nice looking color scheme. However, because of its conservative color choices, it doesn't actually have the full color range available. If you're running on a remotely modern system, you're probably using a terminal emulator, something like Kitty or Alacrity, or maybe even something like Contour or Ghost TTY, I don't know, anything. These modern terminal emulators, they allow true color support. As if you were in a graphical environment, they can display all of the colors that your screen can display. This is what this termguicolors does. What it does is it essentially flips a GUI switch, so to speak. It tries making the terminal, which is just text, a bit more graphical and just a bit more nice to look at. So it enables a wider variety of colors, it enables 24-bit color support, and also any highlighting that is done is now going to use a completely different set of highlighting rules. That's about as much as you have to know. Basically, you can have very simple rules for basic terminals, or you can have very advanced coloring rules for graphical interfaces or for extended terminal interfaces like the one we're about to enable. I hope that made sense. Now prepare your eyes here, because as a result of us changing these terminal colors to GUI colors, it's actually going to completely start ignoring our terminal color scheme and is going to start looking incredibly ugly. So be prepared. We're going to save and we're going to re-enter Neovim now. And yeah, you can immediately tell a difference. Well, for one, the colors are much richer now, right? They're not as bland. You can see this yellow is pretty vibrant. This blue almost hurts my eyes. This pink looks pretty nice though, this reddish pink. So now that we've enabled these quote-unquote ugly colors, we actually want to make use of this new color spectrum that we've unlocked, and we are going to install a color scheme. That's right, it's time to move on to the second phase of this video, which is installing a plugin manager. We are going to install Lazy, and I'm going to try my best to explain to you how a plugin manager works and why we even need one in the first place. So I'm going to spoil it to you right away. You don't need a plugin manager. That's right, you could do all of the plugin management on your own. But to explain how plugin loading works, I think it makes the most sense if we actually install the plugin manager in the first place, so then I can show you some of the things that it does and therefore how we can learn from it essentially. Right, we're going to be loading lazy.nvim, and let me just hop on the website for that right now. Lazy.nvim is a modern plugin manager for Neovim. Okay. So what does this do? Lazy essentially works like this. We set it up, we install it into our own environment, we install it into Neovim. And then what we can simply do is we can provide a list of different plugins that we would like to install. We don't have to do any downloading, we just provide a set of links. We specify, for example, hey, I'd like to tweak these configuration options of this plugin and these different config options of this plugin. Then what Lazy does is it just downloads everything for you, puts everything in the correct directories so that Neovim can load the stuff, and also sets the configuration options for you. So that's pretty neat. It also has many other tools like profiling tools. It can also update our plugins and manage updates automatically, as well as breaking changes and versioning. So it's a pretty fully featured tool we can leverage to really, supercharge our Neovim experience. So down here, there is an installation header. In this header, you can see it says you can add the following Lua code to your init.lua to bootstrap lazy.nvim. And what we're going to do is we're not just going to blindly copy and paste this. I'm now going to spend the next 15 minutes trying to explain every single part of this code. Despite it being pretty short, it is deceptively complex for a beginner like you. So we are going to copy this code and we're going to plop it into our configuration. Since we've set up clipboard synchronization, hopefully it should just be as easy as hitting P on your keyboard and adding a few extra new lines. And just for clarity, at the top we're going to add a comment here, which is just going to say setup lazy.nvim. Goodness, okay, so where do we even begin? The first thing I would like to draw your attention to is this local syntax. I'm not assuming you know all of Lua, so we're going to explain what this is. If you want to assign a variable to something in Lua, there are two ways you can do it. The first way you can do it is you can just specify the name of the variable and then a value. So for instance, I'm going to call this variable, it can be anything. I'm just going to call it my variable. I'm going to set it equal to 3. Now what we've done here is we've essentially put this number 3 into a box whose name is my variable. And we can now pull stuff out of this box using the name instead of the value. So a quick example of this would be print. I can print my variable, and if you were to run this, you would see the output of 3 on your screen. But I wouldn't recommend doing that right now, because what you're going to do is you're also going to run this code here. We don't want to run just yet. We want to run the installation process a tiny bit later. So for now, you basically have to trust me that this would print the value of 3, because my variable holds the value 3. If we set this to a string, like for example hello, it would print hello to your screen. Now the problem with this, and this is arguably the biggest mistake Lua ever made, is that this syntax defines a global variable by default. And what this basically means is this variable is accessible from anywhere. So if you were to chop up your configuration into many different files, like we will do later on in the series, this variable will be accessible absolutely everywhere. And this is not necessarily something that you always want. Global variables are in most cases slower than regular local variables, and they also pollute the global namespace. So what I mean by that is you can't create another my variable in a different file, otherwise the two are going to conflict with each other. What we can do instead is we can mark this as local. And this is what I recommend you do always. There is almost never a need to use a global variable unless you know absolutely what you are doing. And well, let's be honest, you're not going to know what you're doing when you're just starting out. Always remember to add a local, then the name of your variable, and then equal to something. This my variable is going to be accessible only until the end of the file. So once this file ends, it's not available anywhere else and nobody else can access it. This is faster, and just trust me on this, it is going to save you a bunch of headaches if you're writing scripts or programs or anything else in Lua. So we now understand we are assigning a variable called lazy path, but what are we putting inside of this box, right, with the name? We are putting this whole value into this box called lazy path. Now what is going on here then? Now I would like to draw your attention to this. This should seem a bit familiar to you, shouldn't it? You should recall this from the previous video. This is the standard path function, that's right. So what's this doing here then? So to understand that, we have to explain what vim.fn is. Vim.fn is a bridge between Lua and Vim script. If you recall, in the last video I also talked about the kind of really annoying way that some things are Vim script only and some things are Lua only, but there are indeed some niceties that allow us to bridge the two together. This is one of those. Vim.fn allows you to access Vim script functions from Lua. That's literally all it is. You can't invoke Vim script functions in any other way, only using this vim.fn wrapper. So keep that in mind. If you ever encounter a Vim script function and you'd like to use it in your Lua programs, you need to prefix it with vim.fn dot and then the name of the function and any parameters that it might want. So what we're doing is we're calling std path with this data variable. Okay, last time we called it with the config variable because we wanted to know the path of our configuration. But what lazy is interested in is lazy is interested in the path of the data. When Neovim is storing its data, that persists across different sessions of Neovim. So if you quit Neovim and re-enter it, Neovim remembers that data because it's stored in this directory. Now we can use the same trick from the last episode to find out where our data directory is. So let's do that. We're going to use the echo command, which I showcased in the last video. We're going to run std path and we're going to run data. If you hit enter, you can see it spits out a new path now, and that's our .local/share/nvim. And indeed, if you go into this directory, it's going to exist, or at least it should exist, and maybe might even have some data in there already. Now, if it doesn't, don't worry, because lazy is going to create that directory whether you like it or not. So we know that this function is going to return this value down at the bottom of the screen in the form of a string. So what's this double dots here then? This is a piece of syntax that comes from Lua, and it is the concatenation operator. Concatenation is a very fancy word for joining. What this does is this takes one string and it joins it with another string. It literally copy pastes the string on the right hand side onto the end of the string of the left hand side. If you imagine this being a string, right? It's just going to merge the two together. So now you should understand mostly what's happening here. This is going to define a path for lazy to install itself into. It's going to install itself into the data directory /lazy/lazy.nvim. And we're going to verify that later on if it actually did install itself into this directory, because it should. Next up, we have the if statement. The if statement is very simple in Lua. Basically, you say if some condition is true, then execute some code, right? Otherwise, do nothing. But in this case, because of this not keyword, we're saying if this is false, if not this, then execute some code. This function simply checks for the existence of a directory on your system. It checks if that path exists, and if it doesn't exist, it is going to run this code. Vim.loop is very complicated and very advanced. It's way out of the scope of episode 2, okay? We might get into it later on in the future, but it is, we have to start discussing things like event loops and stuff like that, which is just so out of the scope. There's quite a lot to explore within the Neovim space, so I hope you're as excited as I am. Okay, so this is taking the path from above. It's checking if it exists, and if it doesn't exist, lazy is going to install itself into that path. We see this vim.fn here again, so that tells us that this command must be a vim script command. And indeed, if we check out the help page and we try to look for the help page of system, you can see indeed, system is a command. And as per the last episode, it's not prefixed with nvim underscore, which means it's a vim script command. Now, there is a note to prefer vim.system in Lua, but this snippet is using vim.fn.system. There's no difference really. Come on, it doesn't matter that much. Like whether you use the native Lua function or the vim script function, if they both do the same thing, you're fine. You can see this gets the output of a command as a string. And you can see it's going to execute the git command. You should hopefully know what the git command is. If you don't, in very layman's terms, what this command is going to do is it's going to clone down this URL over here, and would you know it, that's exactly this same URL, just with .git at the end. Literally the same thing. And it's going to take all of these files that make up lazy, and it's going to clone them. But where's it going to clone them? Well, it's going to clone them into the lazy path. So this is why we stored it in a variable, because we can access that variable as many times as we like. So this command is going to take lazy and install it in the path that it was looking for initially. Sweet. And then there's this. And this little line is actually really complicated. So before I explain that, let's just run this entire code and see if it works. So we're going to leave Neovim and re-enter Neovim. And hopefully what you should see is that it should stall for a bit. It should just kind of sit there for a little minute doing nothing, and then it should just boot into Neovim like normal, like nothing ever happened. So let's try that. And I'm going to enter, and you see it's waiting for a bit, and here it is. There were no errors or anything, so that means the installation was successful. So let's verify if indeed it installed itself into the directory it claimed to install itself into. So I'm going to run that echo command again to see where the data directory is. It's .local share nvim. So I'm going to ls.local share nvim, and oh, okay, here's the auto completion already kicking in. It exists. You can see the files inside here are identical to the files in the GitHub repository. So the installation was successful, and whenever we re-enter Neovim, we don't have that wait time, because this condition is not satisfied, because the directory now does exist, so it doesn't have to reinstall itself again. Congratulations, you just installed lazy. That was pretty simple, wasn't it? That was deceptively simple. So what's this then? RTP is a shorthand for the runtime path, and a runtime path is a list of directories where Neovim is going to look. It's going to look there whenever it has a question that it can't answer itself. What do I mean by that? Let's say we enter a file, like a CPP file, for example, right? A C++ file. And Neovim is going to want to apply syntax highlighting for that file. The question that Neovim is going to have is, do I have syntax highlighting for C++ code? And this is actually a question it doesn't know the answer to itself. This might come as an interesting surprise to you. It doesn't actually know if it has syntax highlighting. So what it's going to do is it's going to go through every directory that is listed in this runtime path, and it's going to go to each of those directories and it's going to ask, hey, do you have syntax highlighting for C++? If it doesn't, it goes to the next one. And it's like, oh, okay, do you have syntax highlighting for C++? And if it finds it, then it just executes that specific file. And you as a user see the highlights on your screen, similar to how you see the highlights for Lua. You know, this is highlighted differently, the equal sign is highlighted differently, and so on. And this isn't just for syntax highlighting. This is for a vast array of different things that Neovim might not really know about by default. This actually also includes Lua code, believe it or not, and that's how plugin loading actually works. We add our plugin and its directory to the runtime path, and then whenever we try to pull in a plugin, Neovim is going to ask each directory in the runtime path one by one, hey, do you have some code for this specific plugin? No. Okay, do you have some code for this specific plugin? No. And eventually when it comes to our plugins directory, it's going to see, oh, okay, you have some Lua code for this plugin, so I'm going to run that. And that's how plugin loading works. So what we're doing here is we're running a special function, which I'll get into, called prepend. And we're prepending the lazy path where we just installed lazy to the runtime path. And that allows it to do a couple of different things, but most importantly, it allows it to expose its own code. And that allows us, in turn, to interact with lazy and to tell it to install different plugins. So what's this prepend over here? And more importantly, what is this colon doing here? I don't remember there being colons in function calls. So this syntax is a shorthand syntax. It is exactly the same as writing this. Okay, so normally we run functions that belong to something like the runtime path with a dot. But if we need to supply that exact value into the function itself, then we can use this shorthand syntax instead. And the reason why this works is because prepend is a function that operates on an option. So we have to provide what option we want to modify. And in that case, that is the runtime path. So we can provide the RTP itself into the first parameter automatically. I hope that makes sense. These start making sense as you see them used in the moment. And yeah, I hope to really expand on that whenever I can. The prepend function prepends literally adds to the beginning of a list. Because if you look at the help page for the runtime path, also RTP for short, it is an array. it's an array, or in Lua terms, it's a table. So it's not a single string. Instead, it's a bunch of strings, and it's quite literally a table of strings. So there are many strings within a single table. And what that means is you can add to the beginning or to the end of that list if you want to add an entry, for example. We want to add to the beginning. And what that means is that when Neovim asks a question, it's always going to ask lazy first. And that's really it. In theory, you could also do append here. It doesn't matter. But prepend is just a little bit more efficient. Neovim is going to ask lazy faster, right? It's going to ask lazy about everything first, which might just end up speeding up the Neovim execution just a little bit. All right, so much time to explain such a deceptively simple snippet, isn't it? It's quite fascinating how there are so many nuances to just executing a basic Lua script. But as all of this stuff gets slowly drilled into your brain, you're going to really intuitively understand when to use what functions, what the runtime path really is, and so on and so forth. So now down at the bottom, we are going to run our first ever require call. And we're going to require lazy. You can actually see what that looks like, because in the lazy.nvim directory, there is a Lua directory, and inside that there's a lazy directory. We're now in Lua/lazy. And by running require lazy, right, it's going to now look inside of every runtime path directory. It's eventually going to hit this lazy.nvim runtime path directory that we added using the prepend call. It's then going to look inside of Lua, going to look inside of lazy because we're asking for lazy, and it's going to load the init.lua within that directory. Okay, I hope you're following along. So by running require, what this is going to do is this is going to look for a directory called lazy, and if there's an init.lua file inside of that directory, it's going to run that file. Now this is some quite advanced code, but the great part is you don't have to understand this. Neovim is just going to start executing this top to bottom, and therefore is going to set up lazy for us. All right, this is really good. But we don't just want to pull in lazy, we want to run a specific part of code from lazy. And we're going to want to run the setup function. So over here, you can see the next step is to add lazy.nvim below the code added in the prior step. So this is important because we want to have lazy added to the runtime path. And we're gonna run the setup function from lazy with our specific plugins. And here's an example that is provided in the README, but we're going to go by our own rules and by our own example. So the setup function is a special function which sets up lazy itself, right? So we pulled in all the codebase, and now we want to run the setup function from that codebase. Inside of these curly braces, we're going to provide a list of strings. And this list of strings is going to be a list of URLs, two different plugins that we would like to install. So this is what the table syntax looks like in Lua. To define a table, you open curly braces and you close them, and everything that's inside is part of the table itself. All right, so it's time to set up the color scheme because lazy is installed so it can install plugins for us. This is super sick. Now, you can choose any color scheme that you'd like for this series, but my personal recommendation, just because I've been using this color scheme for so long, is Canagua. I know this is not how you pronounce Canagua, but I'm going to still pronounce it Canagua, and there's nothing you can do to stop me. I find this color scheme to be quite beautiful. You can see this is the one we're going to be using. It's got these nice bluish tints to them. Feels a tiny bit like Visual Studio, which, I mean, that might be a good thing for you. It might be a bad thing. It depends. I really like the look of this color scheme though, so we're going to install it. So how do we do it? Well, you can see in the URL, either in the URL or up top here, the path to this is rebelot/canagua.nvim. So we don't actually need the whole github.com beginning. Lazy actually assumes that our code comes from GitHub. So we don't need to provide the whole URL. We can just provide the ending bit here, which is the username and the name of the project. And inside of here, we're going to provide the shortened URL for our Canagua plugin. This is all you need for now, right? To set up a color scheme, this is all you need. Okay, so we've defined it. So now let's quit and let's re-enter Neovim. And you should see that lazy is not only going to set itself up, it's also going to install this plugin for us. So that's quite fascinating. We're going to run it, and here you go. Immediately it boots up, and here we are. Okay, the lazy.nvim UI just started up, and it installed the canagua.nvim plugin, and now it's telling us it's already up to date. Nice. So we're going to now quit out this window with :Q, but just because we've installed the plugin doesn't mean the color scheme is going to enable itself automatically. We actually need to tell Neovim we want to load a color scheme, and we need to do this by running the color scheme command. So you can do this in your editor instance right now. You can run color scheme and you can type Kanagwa, and if you type Kanagwa, it's going to enable the color scheme you want. Now, I specifically want Kanagwa wave, so I'm going to enable that one. When you hit enter, here you go, right? It's changed and it looks gorgeous. And it's much better than what we had previously. But we want this to persist across sessions, because now if I quit and I re-enter, oh look, the color scheme is not applied again, and you would have to run the color scheme command again, right? That kind of sucks. So we want to do this in the init.lua. And we do this using vim.command. So vim.fn is for calling Vim script functions, but functions are not the same as commands. Yet again, another distinction you have to make in your head. Functions are not commands. Functions take in some data and return some data, whereas commands take in just some arguments that you type in the command line, and then they execute something. They change something about how Neovim works. So we're going to use vim.command to run the color scheme command, and it's quite simple. It just looks like this: vim.cmd. I'm just going to put this a bit up here so you can see. .color scheme, and we want to set this to Kanagwa-wave. And now if we save and we re-enter, oh, take a look at that. That is absolutely gorgeous. So much better than what we had before. It looks amazing. We have successfully set up a color scheme and set up our first ever Neovim plugin. That was a very dense introduction to today's video. We're unfortunately not going to have time to split up our configuration into many different files. This video is going on for way too long at this point. I've left timestamps in all of the video because I know the information gets a bit dense at times. So really, if you're stuck on something or you want to re-listen to an explanation, you could hop to any of the timestamps. See if you can really grasp it. I believe the runtime path might be the most complicated to understand. Perhaps it could be the weird duality of Vim script functions and Lua functions, but as we go along, as we use these more often, you're going to start seeing the patterns, you're going to start understanding everything. If you understand everything right now, that's even better. You're already so much more knowledgeable than the average Neovim user. In the next video, we are going to set up syntax highlighting. But not just any syntax highlighting, we're going to set up much more gorgeous and much more detailed syntax highlighting than the one we have built into Neovim. Because as you'll notice, the one built into Neovim actually kind of sucks, and we can improve it. In the next episode, we're installing TreeSitter for that. I'm also going to spend a lot of time explaining the internals of TreeSitter and how it works. If you have any questions, and I assume there will be questions after this video, feel free to leave them down in the comments below. I'll try to explain things as clearly as I can in case you're stuck on some element of Neovim that is really giving you headaches. That was it for me. Thank you so much for watching. Leave a like if you enjoyed it. As always, I'll see you in the next one. Ciao!